Welcome to lesson 2 of quadratic equations and graphing them. Today, instead of using the graphing calculator, now you're actually going to graph these things by hand, so you will need graph paper. What you see in front of you right now is our base parabola in red. F of x equals x squared. And earlier this year we actually graphed these and we studied a number pattern on that, and let's take a look at that number pattern again so we can remember how to plot these things, and we'll be able to plot them much quicker than instead of having to build a table. We did earlier this year, we did some things where we built a table and we looked and said, all right, is there a pattern to these things? And let's just take a look here. Let's put the points in. This is -3, 9. This point here is -2, 4. And then we have -1, 1, 0, 0. And then we have 1, 1 right here. And then we have 2, 4. And lastly, we have 3, 9. Okay, and again, when we studied this earlier this fall, we talked about that there is a pattern between how the numbers are spaced. Like here, there's a difference of 1, and then between this, there's a difference of 3, and then here, there's a difference of 5. And then if you go the other direction, that here there was a difference of 1, and here there's a difference of 3, and here there was a difference of 5. So that we started with our vertex of 0, 0, because our vertex is where the parabola starts, or changes directions, and that parabolas are symmetrical. And if you take a look now, on both sides, I have 1, 3, 5 going up on this side, and then 1, 3, 5 going up on the left side. Okay, so now what are we going to take a look at, and how will we use this to plot something like f of x equals x squared plus 3? Well, the only difference between what's written in blue here and what I have written over here in red is this plus 3 sitting behind. So let's take a look and plot this graph, and then we'll label our vertex and we'll label our axis of symmetry. So taking a look here, if I use the pattern here and I have x squared plus 3, all right? As I said a second ago, that the only difference between the two equations is just this plus 3 at the end. So what does that mean? Well, if you put in 0 for x, what do I get for an answer? If I put in if x and y, and we'll use a table here very briefly. If I put 0 in for x, I get 3 as an answer. So I would plot 0, 3. So that's right here. If I put 1 in for x, 1 squared is 1, 1 plus 3 is 4. And that's right here. If I put 2 in for x, 2 squared is 4, plus 3 is 7. And then let's see here. So 2, 4, 5, 6, 7 right here. All right, I know that parabolas are symmetrical. So the right side is all I really need to calculate here. And then I know on the left side, since this dot is one space away from the y-axis, I'm going to have another dot on the left side that's one space from the y-axis. Since this dot is 2 spaces from the y-axis, I will have another dot exactly 2 spaces away from the y-axis over here, and then I can draw my parabolas. My apologies for them being so crooked here. It's a little hard to draw this with the mouse. Please try to make yours a little bit better. So then now I'm done here with this. Now what is my vertex? Well then, and when you do your work in the book out of the textbook, I do want you to label your vertex. So my vertex here, and we want to take a look at our pattern. Well, the vertex happens to be whatever answer we get that forces our x squared to x part to equal 0. Well, 0 is that here, and it's 0. And what is the answer for when I put in 0? When I get that number as an answer, it's 3. So 0, 3. When I put, what number can I put in for x that causes my x squared to equal 0? That's going to be where I have my, what we call axis of symmetry. Now I'll label this AOS. And as you saw in your chart yesterday, that the axis of symmetry is the same as the x-coordinate of your vertex. The vertex, again, is where the parabola switches directions. And the axis of symmetry is the x-coordinate of the vertex. Okay, let's move on to another graph here. Why don't you take a moment and build an xy axis, and then you can plot this one with me. So pause the video here. All right, yesterday when we did these, we found that these don't shift up and down like our last graph. Our last graph shifted up because there was a number after the x here, the x squared. But now this time the number's inside parentheses with x. So we're going to have a different type of shift. This will be a left or right shift. So if we were to take a look at, and there is a pattern that you should have seen yesterday in that table as we did this. And let's go back to that table real quick and take a look at it, because we did a couple that way. All right, here's one with a minus in it like we're doing on our next example. And let's take a look. Notice that the vertex is 5, 0. 5 happens to be the number that if you put it right here in place of x, 5 minus 5 equals 0. So what number can I put in for x that causes this part to equal 0? That is going to be the x, that's going to turn out to be the x coordinate of the vertex. So let's take a look here. Let's go back to our graph. What number can I put in for x here and cause this inside parenthesis part to equal 0? That's right, it's 2. So that means on my vertex, I'm going to have a vertex of positive 2. So let's see, if I put in x and I build my table and I put in 2. All right, 2 minus 2 is 0, y is 0. So my vertex is actually going to be here at 2, 0. How do we know that? Well, let's keep going with the table and watch what happens. If I go 1 to the right, let's put in 3. 3 minus 2 is 1, 1 squared is 1. So I will plot the point 3, 1. If I put in 4, 4 minus 2 is 2 squared. That's 4. And notice, take a look here. Here's my pattern. 1, 3. So I'm going to go up 3, over 1 and up 3. And now if I really want to, the next pattern is not going to be over 1 and up how many? 5. So I'm going to go up here and put another dot here. Now again, parabolas are symmetrical. So I have the right side of my parabola looking like this. And I'm slowly going up. So that's the right side, symmetrical. So let's see here. Here's my vertex line. My axis of symmetry. My vertex is here, and my axis of symmetry line is right here. So now symmetrical. This dot is 1 space away from this, so it's another dot over here. This is 2 dots away from where my vertex is to the right, so that means there's another dot directly across from it to the 2 to the left. This one is 3 spaces from the axis of symmetry, so there's another one 3 spaces to the left. And then I'm going to draw in this axis. Whoops, that was really bad. So let's see here. Let's get my handy dandy eraser out and erase that. Let's put the dot back in there. I got to do some practicing with drawing parabolas on this thing. My goodness, those are really shaky. Okay, so back to our pattern at hand. We used our 1, 3, 5 pattern to help us plot the right side, and now use the idea of symmetry to plot the left side. So now what's our vertex here? Well, our vertex, and we do want to label these things, our vertex happens to be 2, 0. The 2 comes from what number causes the inside of this to equal 0. And then the axis of symmetry, and you just label that AOS. Happens to be the same as our coordinate of our vertex, so our axis of symmetry is positive 2, which happens to run right here. Okay, and if you notice, everything is the same space away on the right as it is on the left side of the parabola. All right, let's see how well we can use our pattern now to do the third one. Graph f of x equals x plus 3 squared minus 2. Pause the video for a moment, make an xy axis, and write down this function, please. All right, now that you've done that, let's try to use the full pattern without using a table to graph this equation. All right, so when we look at this, what number will cause the inside of the parentheses to equal 0? That's negative 3. Okay, so negative 3 plus 3 gives me 0. 0 minus 2. 0 minus 2, that's going to be negative 2. So what does this all mean? It means that my vertex will, my axis of symmetry and my vertex will start at -3 over here. But notice I have a -2 here. So if, yeah, I will put the t-table here if you need to do that. And probably it might be a good idea when you're first starting to find your vertex. If I put in -3, that's going to then cause the inside of the parentheses to equal 0. 0 minus 2 is -2. So then what does this mean? That means my vertex is at -3, -2, -3, -2, and there's my dot. And what you should notice is actually there's a pattern here. The x part of the vertex will be right here on the style of quadratic equation, and the y part of the coordinate will be right here. So my vertex right here is -3, -2. That's my vertex. So what does that also mean? What is my axis of symmetry? My axis of symmetry then is, okay, my vertex is -3, comma -2. And then what does it mean for my axis of symmetry? My axis of symmetry equals -3. So let's use that idea of the 1, 3, 5 pattern going now. Okay, so let's take a look here. Over 1, up 1, over 1, up 3, over 1, up 5. Axis of symmetry runs right here. Let me just get a dotted line in there very quickly here. Where are my lines? There we go. We want a dotted line. Looks like I don't have a dotted line without arrows, so I'm just going to draw that in by hand, by golly. So our axis of symmetry is right here. So in other words, if something is 3 spaces away on the right, it's going to be 3 spaces on the left. Same idea. So let's go back to the blue marker. So the left one, up 1. This dot is 2 spaces away, so 2 spaces away on the left. And this dot is 3 spaces away, so 1, 2, 3 spaces away on the right, on the left. So now let's see if I can draw our parabola a little better. If you need to, build the table and put the dots in, but try to use that pattern. That is the power of algebra, because we have found, we've studied patterns, we find that these patterns have worked for us, and that they are consistent and constant, and then we can use them to do things faster. Okay, so that's the last example that I have for you. What I'd like for you to do is this page. I want you to do page 523. I want you to do graph numbers 1, 3, 9 through 12, 14, 16 through 18, 25, and 29. All right, good luck. Let me know what I can help you with. Turn it in when you get done.